Okay, so I have a couple homework problems. I'm gonna go over 9-86 and 9-88. So on 86, it says algebraically determine the intersection points and then sketch a graph to confirm it. So to algebraically do this, you set these equal to each other. And then because it's a quadratic, since it has x squared in it, you get it equal to 0. From here, you have a few different options. You can factor with the zero product property, you can do quadratic formula, or you can complete the square. Either way, you're just going to get x equals 3. And then remember, you're not done. This was a system of equations. We're looking for intersections, so you have to plug that in. Y equals 4 times 3 minus 7, and we get 5. So the intersection here is 3, 5, and they only intersect once. To confirm it with a graph, so this y equals 4x minus 7. I assume most of us can graph this line okay. I don't have a ruler here. But it would go like this. So to graph a parabola, if you don't have Desmos, which you won't have on your test, the easiest way I think that you can do that is by making a table. So just pick different numbers for x. We already kind of know where we want it to intersect. You can start at 0. You can do -3 to 3. I'm going to kind of cheat because, like I said, we know where we want it to intersect. So if I plug in 0, 0 squared minus 0 plus 2, we get 2. So 0, 2. Plug in 1, 1 minus 2, -1 plus 2, we get 1. So 1, 1. Plug in 2, 4 minus 4, we get 2. Plug in 3, so 3 squared is 9, minus 2 times 3 is 6, so 9 minus 6 is 3 plus 2, we get 5. So we can see that point is the same. And remember, it's a parabola, so it has the symmetry. So here, plug in 4, we get 16, minus 8 plus 2 is 10. That doesn't fit on here. But using symmetry, I know at -1, it'll also be at 5. And so that's how you can sketch your parabola. On 88, it says for each quadratic function below, complete the square to write it in graphing form. So remember to do this here, you want to subtract 5. So f of x minus 5 equals x squared plus 4x. Complete your square, or make your square, so we can complete it, I should say. Remember, you cut your x's in half. So 4 is missing here, so we need to add 4 on both sides. By adding 4, we have f of x minus 1 equals x plus 2 quantity squared, and then we add 1 to the other side. So we get f of x equals x plus 2 squared plus 1. For part B, we're going to do the same thing. Oh, it says to identify the vertex, sorry. So our vertex here is -2, 1. Remember, it's always H is always the opposite in here, and then K. On part B, we don't have a constant, so you can right away just make your square. So x squared, half of negative 7 is negative 3.5x. So this is going to be 12.25. So we're going to add 12.25 to both sides. Remember, f of x is the same thing as y, and we leave it there for now. So we have x minus 3.5 squared, subtract 12.25, and we get f of x equals x minus 3.5 squared minus 12.25. So here, the vertex is positive 3.5 because it's a minus in there, and then negative 12.25. Part C asks if the vertex is a minimum or maximum for both of these. So both of these parabolas open upwards because our a value is 1. So both of these are a minimum.